All right, I've had requests for chapter 3, number 33, the kangaroo problem. Here we go. This one is a little bit tricky, so if you're struggling with it, you're not alone. So we have a gray kangaroo can bounce across a flat stretch of ground with each jump carrying it 10 meters from the takeoff point. So it's going to go on the ground. We're going to assume the ground is flat. So if I say that it starts at a height of 0 at the beginning, it'll end at a height of 0 as well. That'll be important. And it's going to jump and it's going to have parabolic trajectory. And it's going to jump a distance of 10 meters each jump. It's going to have a takeoff angle of 20 degrees. So this angle is 20 degrees. And I want to know what are its takeoff speed and its horizontal speed. All right, so basically I don't know a whole lot. And so I'm going to start by writing down what I do know. So the first thing I'm going to take note of is once I know the time in one direction, I will know the time in the other direction. So these are related to one another. I know that the acceleration in the y direction is going to be negative 9.8 meters per second squared because that's gravity on Earth. The acceleration in the x direction is 0. There's nothing pushing or pulling on my kangaroo side to side. I'm going to say that my starting position for x is 0 and my ending is 10 meters because I'm going to start at 0 here and end at 10. And in terms of my starting height, that's 0 meters because I'm on the ground, and I'm going to end at 0 meters at the end. Now, sometimes I tell you guys to consider the middle because that's where your velocity in the y direction is 0. That's not going to be helpful in this case because we have no idea what that height is of the kangaroo in the middle. Now, if I knew the height in the middle, then it would make sense to use, or if I'm trying to solve for it. But in this case, I don't care how high the kangaroo jumped. I just care about how far the kangaroo jumped and the velocities associated with that. So at this point, I definitely do not have enough information to solve this problem. So I'm going to think about what else I know. And I know that it's jumping at an angle of 20 degrees. And so I'm going to put that like this. And I don't know my starting velocity, so I'm just going to use v naught. And then I can find my y component. So this would be v naught y and v naught x. And I don't know what those are, but I'm going to create equations for them. So I know that this is the v naught y side over here. This is my opposite to my angle. So I'm going to use sine. So sine of 20 degrees is equal to opposite over hypotenuse, which is v naught y over my hypotenuse, which is v naught. And then I can solve for v naught y. So I'm just going to multiply both sides times v naught. And I end up with v naught times sine of theta, or 20 degrees, I guess, is equal to v naught y. All right, so now I have this. I can take that and plug it in here for v naught y. So I know it's not a number yet, but I do know something about it. And then I can do the same thing for the x direction. So the x side is adjacent to my angle, so that means I'm going to use cosine. So cosine of 20 degrees is equal to adjacent, which is v naught x, divided by my hypotenuse, which is my starting velocity, just v naught. Again, I'm going to multiply both sides times v naught, and I get that v naught times cosine of 20 degrees is equal to v naught x. So those canceled out, and these canceled out. All right, so I'll fill that in over here. And in the x direction, I know that it's not speeding up or slowing down. And because I know that this velocity at the end is also going to be v naught times cosine of theta, or 20 degrees. So let's start by figuring something else out. Let's write the equation for the y direction. So my goal here is to solve for time. So I either need to use the first equation or the second one, but I don't know my ending velocity in the y direction. So I'm going to choose to use the second equation, which is this one. Went ahead and wrote it out, and now I just need to substitute in my numbers. So my ending y position is 0, starting y position is 0. The starting velocity in the y direction was this whole thing, v naught times sine of 20 degrees. And then don't forget to multiply times time, so just do times time. I know I don't know what that is either. Plus 1/2 times my acceleration in the y direction, which we know is negative 9.8, times time squared. All right, and then I can simplify this, and I'm going to solve for time. And what I see here is that it's 0 is equal to something with time, and then plus something with time squared. So I'm going to do a little cheaty thing. I'm going to divide everything by time. Well, 0 divided by time is still 0. And then this, the time just cancels out, and this one, that time cancels out that one. Now, what I'm trying to do is I'm trying to solve for time, and I don't care that there is a v naught in it. I'm just going to make this so that it solves for time. So I'm going to move this to the other side by adding 4.9t. And so I get 4.9t is equal to v naught times sine of 20. And then to get rid of the 4.9, I do the opposite. So I'll divide both sides by 4.9. And I end up with t is equal to v naught times sine of 20 divided by 4.9. All right, this is great and all, but I don't have enough to solve this yet. But I can write an equation for the x direction. So now I'm going to go ahead and do the x direction. And now I'm going to substitute in. So my starting x is 0. Oops, my ending x is 10. My velocity in the x direction is v naught times cosine of theta, which is 20 degrees, times time, plus 1/2 times acceleration. Well, acceleration in the x direction is 0. And be really careful you're not putting in 9.8 for the x direction. It's going to be really an easy mistake for you to make. All right, so this next part is weird. I'm going to put this part the same. But then instead of times time, I'm going to use what I just got over here in neon green. And I'm going to put that here. So times time, but it's going to be v naught times sine of 20 degrees divided by 4.9. Ugh, that's gross. So I'm going to rewrite this. So this is 10 is equal to, and I'm going to go v naught times v naught is v naught squared times cosine of 20 times sine of 20 divided by 4.9. And at this point, I'm going to put it into my calculator and get a number. All right, so when I type that in, I get 0.0655906. Now, if you are using a calculator, you're going to want to keep that number in your calculator because I'm going to want to divide both sides by that number. And so I want it to be as precise as possible. Divide both sides by that. And I get 152.46. And that'll be equal to v naught squared. And so then I just need to square root both sides to get my starting velocity. All right, and so my answer for part A is 12.3475. And then really, I don't want all of those numbers, so 12.3 would be fine, or 12.35 would be fine, and then get rid of that. All right, but because I'm going to do something else with it, I want to use all of those numbers for the moment, or you keep the numbers stored in your calculator and use them from there. Because part B is asking me for the horizontal speed. All right, so what we're going to do is we're going to come back to this triangle situation. And now I have this starting velocity of v naught. So I can plug that in here for my velocity in the y direction, although we don't care about that. Instead, we only care about the x direction. So I'm going to plug that in for v naught here. So I'm going to have 12.3475 times cosine of 20. And that'll be equal to my starting velocity in the x direction. And I get 11.6028, blah, 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 blah. So 11.6 is fine, and that's in meters per second. And so that's your part B. That's your starting velocity in the x direction. If you have any other questions, let me know. This definitely is a tricky one. The hardest part is figuring out where to start. And this is probably the first time you've done something where you get an equation for one thing and then you use it in another. So think back to math class. You've got 2 equations and 2 unknowns. In this case, we had 3 and 3 because we also had to do the x and y components of that starting velocity. Good luck.